I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will briefly discuss about the algorithm, namely random forest algorithm in machine learning. First of all, we should know why we should learn this random forest algorithm, or why we should know about this random forest algorithm. Random forest algorithm is a popular ensemble learning algorithm in artificial intelligence and machine learning that combines multiple decision trees to improve predictions accuracy. It handles complex data sets, reduces overfitting, and is versatile for both classification and regression tasks. Random forest is widely used in AML, that is artificial intelligence and machine learning, for its robustness and the ability to handle high dimensional data. This is the main application of random forest algorithm. It is a powerful tool for predictive modeling and data analytics. We'll see briefly about this random forest algorithm. Before going into the random forest algorithm, we should know about the ensemble based learning approach. What do you mean by? It combines the multiple models for better accuracy. Ensemble learning merges the results of multiple models to enhance prediction accuracy and reduce errors compared to single model. Random forest uses many decision trees. How it uses the many decision trees? Random forest is a popular ensemble technique that builds several decision trees and combine their output to make final predictions. Each tree uses different data subsets. How it is using different data subsets? Every tree in the forest trained on a different random sample of the data set using unique subset of features which adds variety of features. And the final predictions, how the final predictions will happen by voting or averaging. For classification tasks, the most common class among all trees is chosen. For regression, the average of all tree predictions is used, and it reduces the overfitting and boosts robustness. How it will happen? Combining multiple features and diverse models helps avoid overfitting and improves the model's performance on new unseen data. And it performs well with the complex and noisy data. In the sense, the random forest handles messy and high dimensional data effectively, making it suitable for a wide range of practical problems. This is what about ensemble based learning approach. Then we should know what is a random forest. A random forest is a machine learning algorithm that builds and combines multiple decision trees to make predictions. So it combines the multiple trees. So we'll see one by one. It operates under ensemble learning concept. It operates under the ensemble learning concept where many weak learners, that is individual decision trees, are combined to form strong learners. The algorithm is applicable to both classification tasks and also for regression tasks. The classification is used for such as predicting categories and regression tasks like predicting continuous values. By aggregating the output from several trees, the final prediction is more stable and accurate. In classification problems, it uses majority voting, and in regression, it averages the predictions of all trees. And what is the intuition behind this random forest? We'll see one example. The intuition behind random forest is similar to making a decision based on multiple opinions. Imagine asking several friends for advice on a vacation destination. Each friend gives a suggestion based on their unique experiences and preferences. When you collect all responses and choose the most popular one, You're essentially applying the same logic as a random forest. In the algorithm, each decision tree is trained on a different subset of the data and features, and the final prediction is made by combining all the tree's output either through voting or averaging. See, if I have n number of friends, so n number of friends wanted to go to vacation to some places. Each and every person will have some experience with some other tourist places. So what we'll be doing is each persons will be making the tree, and then we will be combining we'll be making it as a tree, and then finally we'll be checking their decision trees output based on the voting. Will come to the conclude voting or averaging will come to the conclusion what we should do, which place we have to go for the vacation. And how this algorithm will work, so just overview will see. The random forest starts with a complete data set that contains raw rows data samples, that is column rows data samples. Here this is the rows, and also columns features and target labels, and columns features and target labels. The algorithm builds multiple decision trees where each tree is trained on a randomly selected subset on the data of the data. Additionally, at every node of each tree, only a random subset of feature is considered when making a split. This randomness ensures that each tree is unique. After training, when a new sample is given, every tree is independently makes a prediction. All these predictions are then aggregated either by voting either by voting or for most frequent classes in classification tasks, or by averaging, that is regression. Voting means classification, averaging comes under that will be using it for the regression tasks. Next, we'll see step-by-step working principle of this random forest. So the first step is the working of random forest can be broken into several clear steps. The algorithm randomly selects the different subset of data from the training set using the method called bootstrapping. That is bootstrapping. We can call it as sampling with replacement. We can call it as sampling with the replacement. Each of these subset is used to train a separate decision tree. When building these trees, only a subset of the total feature is considered at each split, which introduces further randomness. Once the trees are trained, they are used to make predictions on new unseen data. For classification, for classification, each tree gives a class label. Each tree gives a class label, and the final result is the one with the most votes, whichever is giving the majority vote. For regression, the numerical predictions are averaged to get the final output. So in this way the process will takes place. Next, the key features of random forest. One of the key strength of random forest is the ability to handle missing data effectively. The algorithm can still make predictions even when some data values are absent, reducing the need for pre-processing. Another important feature is ability to determine importance of each feature in the data sets. This is helpful for feature selection and understanding the model's decision making process. Random forest also scales efficiently. It scales the efficiently to large and complex data sets, making it suitable for a wide range of practical applications. Its flexibility allows it to perform well in both classification and regression scenarios, adding to its popularity. Next, why random forest works well. Wha- How we are going to analyze or how you are going to validate. Random forest is effective because it introduces randomness in both the data and features used to build used to build each tree, making each tree in the forest slightly different. This diversity allows the ensembles to generalize better to new data and reduces the risk of overfitting, which is common in single decision trees. By combining multiple models, it averages out their errors and produces more accurate predictions. Additionally, the algorithm is capable of learning from complex data patterns that may not be captured by simpler models, which is why it performs well across a variety of tasks and data sets. Next, what are all the assumptions to be made in random forest? Assumptions in random forest. Random forest works on the assumption that each decision tree in the ensemble operates independently and does not rely on outputs of other trees. Each tree is constructed using a different subset of training data and features, which helps the model to learn various patterns and reduces the chances of correlated errors. For the algorithm to work effectively, it is important to have sufficient amount of data so the trees can capture diverse patterns. The core idea is that by combining predictions from different trees, the final result will be more accurate. It will be giving us more accurate single tree single tree output output. So it will gives us maximum possible, that is predictions. Next, the use cases of example. Random forest has a wide range of real world applications due to its flexibility and high performances. In the medical field, it is used to diagnose tasks where it can predict diseases based on the patient symptoms and medical history. In finance, if you are going into the finance, random forest helps to detect fraudulent transactions by identifying patterns that differ from normal behavior. In stock market predictions, it uses historical and technical data to forecast price movements, the stock movement. It is also commonly used in sentiment analysis, where it determines whether text data, such as in this case, it predicts or it determines whether text data such as reviews or text data, so we can call it as the reviews of reviews or tweets expresses a positive or negative sentiment. And this is the diagram for random forest algorithm. See here, the person wanted to go to tour to somewhere or vacation to somewhere. Each persons will have some decisions and they'll be getting the output. The output may be class A, and so many outputs will be there. And the bagging, voting majority, the random forest algorithm, it starts with where the training data set that includes input features and then corresponding labels, that is the target values. This data is used to teach the model how to make predictions. And an instance refers to a single row. Here, instance refers to the here. This refers to the single row record in data set. Each instance has a set of features and labels. These instances are used during both training and testing phases. And what do you mean by model training here? The during training, random forest creates multiple decision tree. Each tree is trained randomly selected subset of the training data using bootstrapping. Here we are using the algorithm called bootstrapping. We are going to use it, and random feature selection to increase diversity. Next, the decision means what? Each decision here, the decision trees process the input features of data instance, follows its learned rules, and arrives at a prediction or decision for that instant. Next, model testing. Once the trained, the random forest model is tested using the new unseen data. This step assembles how well the model generalizes the real world input and predicting the output. Predicting the output. Here, wording method we are using. Two classes are there. Class B is one. So we are going to choose the finally we are going to choose A. So there are fundamental models inside a random tree. They make decisions by splitting data to various future values, forming branches that eventually lead to predictions or prediction outcomes. So in this way, it will be helping us. So training data, instant model training, and decision trees. So coming into the summary, in summary, random forest is a robust and versatile algorithm that uses multiple decision trees to improve prediction accuracy. And it leverages randomness in both data sampling and feature selection to create diverse models that work well together. The final prediction is more reliable because it is the result of aggregated output from many models. It works well with both categorical and continuous data and can handle missing data values and relevant features because of its power and ease of use. Random forest is considered a go-to model. Because of its power and ease of use, random forest is considered a go-to algorithm for many real-world machine learning tasks. So this algorithm is very important algorithm. Hope everyone enjoyed the random forest algorithm. The remaining things we'll discuss in the next lecture. Thank you.